Now that you're familiar with how to undo various operations, you should be ready to go on to equations. So what equations mean is that you will have an equal sign. And it's best to envision it as a set of, say, balancing scales. Please excuse the poor quality of the drawing. So if you have a balancing scale, the weight on both sides has to be equal for it to be in balance. So similarly, for equations, everything on both sides of the equal sign has to be the same. So for example, let's say x plus 2 equal to 10. It just means that everything here is equal to everything here. So x plus 2 is the same weight as 10, if you want to say that. So if we have a balance, we have x plus 2 on one side and 10 on the other side, and they weigh the same. Now, obviously, we can see that for x plus 2 to be the same as 10, x will have to be 8. So because 8 plus 2 is the same as 10. So the only possible way for the balance, but for the scale to remain in balance, is for x to be 8. Similarly, if we have, say, another scale, if we have, say, 6y on one side and 42 on the other side, the only way for the balance to remain balance, I guess, balancing scale to remain balance, is for y to equal to 7. Because only when y equals to 7, then we will have 6 times 7, and we will have 42, which is equivalent to the 42 on the other side. So, of course, these are some of the pretty simple examples where we can just guess what the pronumerals is, because they are very straightforward, involving simple addition and multiplication. But sometimes the expressions may not be so straightforward, and then we will have to resort to the methods we developed in the previous lesson, which is to invert or undo the operations involved in the expression. So for example, let's have 3x plus 2 equal to 14. So in this particular case, 3x plus 2 has to equal to 14. So once again, if we have the balance here, (3x plus 2) has to be equal to 14 for the scale to remain in balance. So what we can do is to undo the operations steps by step here. So to undo 3x plus 2, the first thing we can do is subtract 2 from it. However, to ensure that the scale remains in balance, we have to subtract 2 from this side as well. Otherwise, there will be less on this side and the scale will tip. So after we have taken 2 from both sides, we're left with 3x equals to 12, as 14 minus 2 is 12. Our next step, next step in undoing the operations here, we divide it by 3, since divide by 3 will invert the multiplier by 3 here. Once again, to ensure that the scale remains in balance, we have to do the division on the other side as well. So in the end, we have x here, and then 12 divided by 3, we have 4. Of course, the balance is just an illustration. We can do without and use purely mathematical symbols to complete the process. So, for example, if we have x minus 1 divided by 5 equals to 3. Of course, here, to undo the divide by 5 here, we have to multiply this side by 5. But to ensure that the two sides are equal, we have to multiply by 5 by the other side as well. So, since multiply by 5 undoes divide by 5, we will have x minus 1 left here. And 3 multiplied by 5, we have 15 here. 3 by 5 is 15. And now we have to undo the minus 1 here. And to undo a minus, we plus. And once again, whatever you do on one side, you have to do to the other to ensure that the equation remains in balance. So, plus 1 undoes minus 1, so we have x. And 15 plus 1 gives us 16. 16. And let's try a few more examples. For example, say m plus 27 equals to 59. So plus 57 here, we undo, let's say called A. We undo the plus 27 by minus 27. And once again, we have to apply it to the other side to ensure that the equation remains in balance. So we end up with m, and the 59 minus 27 gives us 32. Now, next one. A minus 16 equals to 9. So we have a minus 16 here. We undo it by plus 16. And then to ensure that the equation remains in balance, we add 16 to the other side of the equal sign as well. So these two cancel out. We have A equals to 9 plus 16, 25. For multi-staged ones, let's say we have 2a plus 5 equals to 7. So first thing we have to do is we have to cancel out the plus 5, which we'll do by minus 5. And we'll do to the other side as well. So we have 2a equals to 7 minus 5, 2. So we have 2a equals to 2, and we can cancel out this 2 by dividing it by 2, which we have to apply to the other side as well. So 2a divided by 2 is a, and we end up with 1. Now, the next one. x plus 3 over 5 equals to 2. We cancel out the 5 by multiplying it by 5. So multi times 5 cancels out divide by 5. And whatever we do here, we have to do to the other side as well. So we have x plus 3 equals to 10. And then we subtract 3 to get rid of the 3 here. 3, so we end up with x equals to 7. And next one, we have p over 3 minus 6 equals to 15. We cancel out the minus 6 by plus 6, with plus 6 here as well, so we have p over 3 equal to 21. And then we cancel out the 3 here by multiply by 3, which we have to do to the other side as well. And we end up with p equals to 63. Now for f, we have 10 minus 3m equals 25. Okay, for this step, what we can do is that we minus 10 from both sides to cancel out this 10 here. So we end up with minus 3m equals to 15. Now we cancel out the minus 3 by dividing it by minus 3, which we have to do to the other side as well. So we end up with m equals to minus 5.